Imagine boarding a spacecraft bound for Jupiter knowing that Earth is not just far away, but effectively lost to you forever. Not because the rocket can't turn around, not because the fuel runs out, but because the environment of Jupiter would make your body fundamentally incompatible with life on Earth ever again. This isn't science fiction. It's orbital mechanics, radiation physics, and human biology colliding in the most unforgiving way possible. A mission to Jupiter is not just longer than a Mars mission. It is exponentially more hostile. At its closest, Jupiter lies roughly 628 million kilometers from Earth. At its farthest, over 930 million kilometers. Even traveling at speeds comparable to our fastest interplanetary probes, the journey would take between 2 and 6 years one way. That means astronauts would spend nearly a decade in deep space before even attempting a return. But distance is the least terrifying part of this equation. The real problem begins long before you arrive. Jupiter sits inside the most intense radiation environment in the solar system. Its magnetic field is the largest structure of its kind around any planet. It traps high-energy particles and accelerates them to near-relativistic speeds, creating radiation belts thousands of times more powerful than those surrounding Earth. For comparison, astronauts aboard the International Space Station receive roughly 150 millisieverts of radiation per year. Near Jupiter, unshielded exposure could deliver lethal doses in hours, not years. Hours. Even robotic spacecraft struggle to survive. NASA's Juno probe required titanium radiation vaults just to protect its electronics, while making brief passes through Jupiter's magnetosphere. Now imagine a human body subjected to that environment for months. Radiation at this scale doesn't just increase cancer risk. It shreds DNA. It damages neural tissue. It degrades blood vessels. It accelerates cardiovascular aging. At high enough exposure levels, it causes acute radiation sickness, nausea, organ failure, immune collapse. And shielding isn't a simple solution. Thicker metal walls create secondary particle cascades when struck by high-energy ions, multiplying internal radiation exposure. The very act of protecting the crew can intensify the damage. Radiation alone would already make a return unlikely. But Jupiter has another secret. It doesn't have a surface. There is no ground to stand on, no solid terrain to plant a flag. Jupiter is a gas giant composed primarily of hydrogen and helium. As you descend, pressure increases continuously. The clouds give way to deeper and deeper layers of compressed gas until, thousands of kilometers below, hydrogen behaves not as a gas, but as a metallic liquid under crushing pressure. The gravitational pull at the cloud tops is already 2.5 times stronger than Earth's. That means your body would instantly feel more than double its normal weight. Your heart would have to pump against far greater resistance. Your muscles would strain just to move. Your skeleton, already weakened by years in microgravity during the journey, would suddenly face forces it was never conditioned to handle. Consider what happens to astronauts after 6 months in orbit. They lose 1 to 3% of bone density per month. They return to Earth dizzy, weak, sometimes unable to stand without fainting. Now stretch that exposure to 5 or 6 years in deep space. Then double Earth's gravity upon arrival. A body that has adapted to weightlessness cannot suddenly perform under crushing force. The cardiovascular system would struggle to circulate blood. Orthostatic intolerance would become catastrophic. Even if artificial gravity were used during transit, the constant transitions between microgravity, simulated gravity, and Jupiter's intense pull would impose extreme physiological stress. And that assumes you never attempt to descend deeper, because the deeper you go into Jupiter's atmosphere, the worse it becomes. Wind speeds exceed 600 kilometers per hour. Storm systems larger than Earth rage continuously. The Great Red Spot has persisted for over 300 years. Temperatures fluctuate wildly. Pressure climbs until it would crush any known spacecraft. A human descending into Jupiter would not land. They would be compressed. Now imagine surviving in orbit instead. Perhaps a station around Jupiter, a long-duration research habitat studying its moons, Europa, Ganymede, Callisto. Even there, the radiation environment remains brutal. Europa alone sits within radiation belts that would deliver fatal doses in days without massive shielding. Any mission architecture would require thick protective barriers, increasing mass, increasing fuel requirements, increasing launch complexity. And here we encounter another wall, the rocket equation. To send a human-rated spacecraft to Jupiter and back requires enormous delta V. More fuel means more mass. More mass requires more fuel. It is an exponential spiral that rapidly becomes impractical. Chemical propulsion strains under the requirement. Nuclear thermal engines improve efficiency, but not enough to make Jupiter routine. Every kilogram sent must survive a journey measured in billions of kilometers. Even communication becomes fragile. At Jupiter's average distance, light takes between 35 and 52 minutes to travel one way. A message sent from Earth arrives nearly an hour later. A reply takes another hour. Real-time support is impossible. Medical emergencies become self-managed crises. Psychological strain compounds over years of isolation. And then there is the human factor. Extended deep space travel exposes astronauts to chronic microgravity unless artificial gravity systems are perfected. Bone density loss could exceed 40%. Muscle atrophy would weaken core stability. The heart could shrink by 15 to 20%. Fluid redistribution alters vision. The immune system weakens. Radiation compounds every vulnerability. By the time astronauts reach Jupiter orbit, their physiology is no longer optimized for Earth. It is adapted to survival in artificial habitats. Returning to Earth would mean reintroducing full gravity after nearly a decade away. A heart weakened by years of reduced load may not tolerate the sudden demand. Bones thinned by radiation and microgravity may fracture under normal walking stress. Arteries aged by cosmic radiation may struggle under Earth's circulatory pressure. And the cumulative radiation dose from both deep space and Jupiter's magnetosphere could permanently elevate cancer risk beyond acceptable thresholds. The transformation is gradual, but it is profound. The body that departs Earth is not the body that would attempt to return. Even if propulsion, shielding, and engineering were perfected, the human organism remains the limiting factor. Jupiter is not simply farther than Mars. It is embedded in a radiation fortress, wrapped in gravity wells, surrounded by lethal particle storms. The environment around Jupiter does not merely challenge human exploration, it resists it. Some argue that missions would focus on Jupiter's moons instead. Europa's subsurface ocean is one of the most promising locations for extraterrestrial life in the solar system. But Europa orbits within Jupiter's radiation belts. Any surface mission would face constant exposure. Habitat shielding would need to be buried beneath ice or regolith. Every EVA would carry risk. The farther from Earth we travel, the more we confront a brutal truth. Space does not want us there. The energy required increases. The radiation intensifies. The communication delays stretch. The human body degrades. A Jupiter mission lasting 10 years would not just be an expedition, it would be a biological transformation. Bones altered, cardiovascular systems weakened, DNA scarred by radiation, psychology reshaped by isolation. Returning to Earth after such a journey would not feel like coming home. It would feel like entering a gravity field your body no longer understands. This is the harsh reality. Jupiter is not a destination like Mars. It is a threshold, a boundary where engineering meets the limits of human physiology. Radiation doses measured in sieverts, not millisieverts. Gravity measured in multiples of Earth's pull. Distances measured in billions of kilometers. The solar system grows less forgiving the farther we venture. And while robotic probes can dive into Jupiter's storms and transmit data until they fail, a human body cannot be rebooted. It cannot be shielded indefinitely. It cannot be rebuilt after years of molecular damage. Anyone who goes to Jupiter is not simply taking a long trip. They are entering an environment that rewrites the rules of survival. And once those rules reshape the body, there may be no safe path back. Not because we lack courage, not because we lack ambition, but because Jupiter demands a price written into physics, radiation biology, and gravity itself. And the human body was never designed to pay it. I really hope you enjoyed this video. If you're curious about the limits of human space travel, consider subscribing. I'll see you in the next one.